Hello everyone. So today we are solving a question of JEE ADV 2017. This is from the topic of the kinetic theory of gases. So let's start from reading the question. So they're given a flat plate which is moving normal to its plane through a gas under the action of constant force F. The gas is kept at very low pressure and the speed of the plate V is much less than the average of speed U of the gas molecules. Which of the following options are true? So let's first imagine what our question says here. So they're given a plate something like this. Okay, I'm like trying to make it in 3D. Suppose this is our plate. Okay, now it is moving with some velocity v here. And what is the speed of the gas molecules that is present here? It is u. Okay, and they are saying that it is under the action of a constant force F. So they're given a constant force F, which is being applied on this, and with like gases are opposing that force, so that it is moving with a constant velocity v. Okay, so let's first write what can be the what are the number of particles that are acting like they are putting force in this. Okay, so let's suppose what can be the area of this. We'll consider it at A. Okay, let me write all the terms. A is the nothing but area of the plate here. Okay, now if we see, so what can be the number of particles that are colliding? So if we write about the number of particles, it will be something. Let's suppose n is the particle per unit volume. So if we have to multiply it with volume present near this plate, so that we can get the number of particles that are colliding. So it will be, this is number of particles per unit volume. If we multiply it with area, and in time dt, it will cover some distance here. That will be nothing but v dot dt here. So n into a. Okay, now I want to know that suppose there are n particles here. So some of them will be moving this side and some of them will be moving that side also. Like there is no possibility that particles are moving towards the plate and particles are moving ahead from the plate. So we can write u plus v. We have to consider which are the plate are coming towards our plate here. U plus v dot dt. Okay, but as I said that we only have to consider the particles which are coming to our plate here. So we will take a half here, so that we can say that n by 2 particles are coming towards it and n by 2 particles are moving away from it. Okay, so this is the number of particles here. Now what will be the pressure applied by them? So for pressure we have to find first force here. So this is the mass or the number of particles here. Let's consider mass of one particle as m. Mass of one particle is m. Now if you multiply it with n, so half into n into m into a u plus v dot dt. So this is nothing but the mass of the complete particles which are colliding here. Okay, now if we say what can be their um, momentum, because the change on momentum will only give us the force here. So we know that the what will the momentum impart? Let's suppose m times u plus v. It has this velocity, like it is, let's suppose this is the plate here. Okay, a particle of mass m coming, and it is moving with some velocity of v. It is moving with u. So after it strikes here, so it will bounce back with the same speed of u plus v here. So what is the change in momentum came here? So it has a direction change also. So that's why we will write mu plus v minus mu plus v. So it means actually the change of momentum is nothing but the 2m of u plus v. This is the number of particle or the mass of particle. This is the change in momentum here. Okay, this is actually the change in velocity actually. Now if we multiply it half into n into m into a u plus v dot dt into what is the change in momentum? It is 2 times u plus v. And we know that the dp by dt, that is change in momentum per unit time, is given as the force here. So if we divide it with dt, so we will get this is equal to the force. Let me write it clearly. It is nothing but half into n into m into a into u plus v square. Okay. Similarly, if you want, like, for the forces, also you can see that, as I told you, some particles are moving away from it and some particles are moving towards it. So at this point also, some particle will be moving towards it and some particle will be moving away from it. So we know that for this particle, what will be the relative velocity? It will be nothing but u minus v, because it is, the plate is actually moving away from the particles. So the all the calculations will be same. Instead, what we will get is, this is the force in front side, so force in front, and what will be the force at backward side? It will be nothing but half into n into m. The only change we will get is u minus v whole square, okay, into a. Now we want to, like, calculate what is the net pressure here. So pressure will be nothing but force but by area. So P will be equal to, not P, momentum, it is not momentum. P will be equal to, if I sum this, half into n m into a, is the sum of u plus v whole square plus u minus v whole square divided by area here. We cancel all this, so we will get is half into n into m into what is a plus b square. Oh, sorry, they are opposing forces, so I have to subtract actually them. Minus, okay. So what is a plus b square minus a minus b square? We will get nothing but 4ab, that is 4 times uv. If we cancel it, so this is the net pressure, nmuv. Okay. Now let's check one of our options. So it says that the pressure difference between the leading and the trailing phases of the plate is nothing but proportional to uv. So this option is absolutely correct here. Now we have to tell the resistive force experienced by the plate is proportional to V. Okay, so let's first imagine what will be the resistive force experienced by it. It will be nothing but due to the particles here. So which is definitely gonna be proportional to the velocities here, because they are applied force with the change in momentum and all. So the pressure is also proportional to our U and V. So this means that the resistive force experienced by the plate will be also proportional to the B here. So we will like mark this as a correct option our. Now, similarly, the plate will continue to move with constant non-zero acceleration all the times. So this is not true actually, because at some time, as the resistive force is also acting here, so once it will attain like a balanced force and it will attain a terminal velocity, so then no longer it will be accelerated here. Okay. At the later time, external force, as I said earlier in the C option, that some time will come when the F will be balanced by the resistive force, then only this condition will be false. Hence our options D is also correct, and the correct options are A, B and D. Thank you everyone.